Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 120. Find number of coins to place in tree nodes. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So yeah, basically this one you have these rows, but the idea is because you're already given a rooted tree, rooted at 0, everything is just recursion. The thing you want to do is just figure out how to keep the recursion cheap, right? For example, if you think about a linked list, like a tree that is shaped like a linked list, if you return every element to sort or even not to sort, it's going to be n squared because you're returning n elements, and then you're basically doing the classic 1 plus 2 plus 3, or maybe if you want to count the other way, then n plus n minus 1 plus n minus 2 dot dot dot, which is classically n squared, right? Yeah, and basically for this one, like I said, it's just about figure out what to add up. And here you want to find the maximum product of 3 distinct nodes, and in that case there are really only 2 cases that you want to consider. Well, I mean, other than having less than subtree is less than I, having less than 3 nodes, is that, so if you want a maximum product, then there are only 2 cases, right? One is all 3 numbers are positive, or the 2 big negative numbers and 1 positive number, right? So that's basically the idea for this one, because from those 2 things, the most that you're ever going to return is 5 numbers. And yeah. And basically from that, then it doesn't matter how many times you do recursion, you just, have 5 numbers to sort or something like this, give or take. I mean, it's not quite. And also, it really depends on how you end up writing it, but yeah, you can certainly do it that way, right? But it depends how you want to write it. But I did it actually a little bit sloppy, but it still should be fine. Or at least it worked, but. But yeah, all right. So basically, the idea, like I said, is recursion. So we're going to go over the code. First of all, we're going to return the. We're going to construct the edge list. I had not enough sleep, so I can't even talk through this. But yeah, this part, edge list, we just convert it. It's fine. And then we do a recursion from the root. And here we just keep track of the positive and the negative numbers. Here, as we said, we just keep track of the positive numbers and the negative numbers, separate them out. We do a recursion. We count the number of nodes, counting the number of nodes and the subtree. Hopefully, I don't have to explain because you probably shouldn't be attempting hard problems if you haven't gotten that basics down. But yeah, so here is just recursion and throwing the answer up. And here, the way that I did it is a little bit suboptimal, but should be fast enough if you do the math. But you can be a little bit you could be skeptical, but and then it just we'll go with the complexity in a second, or at the end. But basically here I add the positive numbers to positive, negative numbers to negative. I sort the positive numbers in reverse, and I sort the negative numbers just regularly. And here it's the critical part, is that if I have more than 3 positive numbers, I trim. If I have more than 2 negative numbers, I trim. And here are the rows from the problem. If we have less than 3 nodes, then we just give it 1 coin. Otherwise, we set it to 0 and then see if we can make it a bigger positive. And in a greedy kind of way, it's either going to be, like I said, the 3 positive numbers, the product of them, or the 2 really big negative numbers, so go the smallest but the biggest absolute value, times the biggest positive value. And that's pretty much it. And then you just return them. So there are 2 questions probably for this, or there are a couple of questions for this one, but the most pressing is probably, hey, you do a sorting here. Isn't this like some crazy complexity? And the idea is because that we actually do a trimming, and that this becomes critical, is that this sorting for each number, other than the core 3 or 5 numbers or whatever, how do you want to say it? Every other number is only going to be sorted once and then get removed right afterwards. So in that sense, in the worst case, this is going to be n log n because of the because if all the numbers are under the same tree or something or same node, then you have n log n because you sort in this case. There is a smarter way to do this, which is that instead of writing it like this here, you could have used a heap of size k being size 3 for positive numbers and 2 for negative numbers. And of course log 3 or log 2 is is a constant effectively, and because of that you become O of n log 3 or n log 2 or whatever, which is obviously just O of n. So if you do it that way, it's going to be linear and much cleaner and much faster. But of course log n and log 3 is, I guess there is a difference, but it is fast enough for this problem and this challenge. So yeah. And as usual, I usually go over my wrong answers, and I have 2 wrong answers. And honestly, I just need more sleep because I just had some typos. For example, this one initially I had like to the -3. Maybe that was just wrong. Oh yeah, that is definitely wrong. I don't know why I thought that was right. Well, like I said, more sleep. But instead I reversed it. I spent some time fixing this, adding reverse. But when I reversed it, I forgot to correct the formula, so that was one wrong answer. And then the second one was just literally more a typo. I had this, and then I had to fix it. But I was like, oh, I didn't even copy and paste, I don't think. I think I just typed it out, but I was thinking too dumbly. So yeah. So 2 wrong answers, both silly, so I don't even think it's worth going over other than to mentioning it. Like I said, this is linear time, linear space, and that's what I have for this one. Let me know what you think. And the linear space, I mean, it's lower bound because of the answer, but I guess you can, depend on how you want to say it, it's, But yeah, so you have the top, which is just edge list, and then now this is the recursive function. You could do this a little bit cleaner, but just to kind of give you a taste. But yeah. That's what I have with this one. Let me know what you think. And yeah, you could watch me solve it live in the contest now. How did I... Oh, what a silly mistake. The idea's in my head, but 3 wrong answers because I just missing some logical things. Oh, that's pretty sad, actually. That's pretty bad. 2? Only 2? Still. Taking a long time on this one. Josh already finished. Congrats. I can't even get my words out. Alright, let me finish. Congratulate him later. The size of the subtree of I is less than 3. How do I place? Okay, so there's a coin in 1, 2, 3, 4, 5. Is that it? And then here, just 3 distinct nodes in subtree. Maximum product. I don't get it. Why is this hard? And it's rooted at 0? Yeah. They give you the root. Oh, it's any number in the subtree, not just... And it's just tricky cases with negative numbers. Okay, so what do we keep track of? We return 3 biggest and 3 smallest, and that should be good, right? So you just return 6 numbers. I guess, I don't know. What is cost again? Oh, I don't even know what cost is. Oh, yeah, okay. That's just, the labels that are here. That's really awkward, but okay, fine. Yeah, again, just yeah, should be okay. Okay, yeah. I feel dump Q3 or Q2. You have to be careful not to reuse same numbers. Definitely some edge cases there, but okay, I got it. We want the biggest. No. It's gonna be a mess to no, we could do this. Okay, fine. Make sure that it runs. Oh yeah, okay, fine. Kind of runs. Okay, and now. Right. That includes this number, right? I actually don't. Okay, yeah, okay. Okay. Yeah. Just one, right? Okay, and then now. Well, that's not good, but not all these numbers. It may not have all these indexes. Why? Tell me why. One. Count is 0 to 1 because I never set up to link this. Oh man, I'm really off today. Well, this is a start, but not the start I would like. Let's double check real quick. Okay, so that works. This is what? Did I accidentally remove things? This is right. Probably should test a big case, but I didn't actually expect that actually. Did I have the mod? No. Huh. That's actually surprising. I wish this is more easy. Okay, this is actually pretty easy to read. Oh, I am dumb. I rewrote the thing and then I forgot to take that into account. Can't even see what's going on here. Am I still wrong? I'm still wrong. So, I mean, would have gotten a wrong answer. I deserved wrong answer. But okay. Yeah, okay. Why am I still wrong though? Oh, why did I? You only need 2, that's why. But then I did it in a weird way. Oh man, so many mistakes today. Alright, submit. This isn't even a hard contest, said the guy who keeps getting wrong answers. But I'm just not having a good day, I think. Didn't go to sleep yet, and that's what happens. I need a visualization of this. I'm doing 0, so 0 is definitely wrong. Oh man. So this is... Oh man. Oh, Larry. How do you keep on it? I am just really off today. It happens, I guess. Alright. I mean, yeah. Go. What it? Already starting off weak, but let's go. Uh-oh, that seems like it's gonna be on like Q4 or something. But it is such bad code, but gotta get it done quick. 1073. Oops. Thought that looks strange. Okay. Whew. That was hoping for no type.